Far beyond our solar system, astronomers have discovered worlds that challenge everything we know about planets. Among the most extreme of these discoveries is a planet hotter than many stars. This extraordinary world is known as KELT-9b. It orbits a massive blue star located hundreds of light years away from Earth. Unlike most planets, KELT-9b circles its star at an incredibly close distance. One full orbit around its star takes only about 36 hours. Because of this proximity, the planet is constantly bombarded by intense stellar radiation. Temperatures on the planet can exceed 4,000 degrees Celsius. That is hotter than molten lava and even hotter than some small stars. Under these extreme conditions, the planet glows with an intense heat. Its atmosphere becomes superheated by the powerful radiation of the nearby star. Massive heat waves ripple across the planet's atmosphere. The entire world appears incandescent as it absorbs enormous energy. Powerful tidal forces stretch the atmosphere toward the star. Scientists classify KELT-9b as a type of planet known as a hot Jupiter. These giant gas planets orbit extremely close to their parent stars. Using advanced telescopes, astronomers study the light passing through the planet's atmosphere. Spectral analysis reveals unusual chemical signatures shaped by extreme heat. These observations help scientists understand the most extreme planetary environments. KELT-9b stands as one of the hottest and most hostile planets ever discovered in the universe. As scientists studied KELT-9b more closely, they discovered that its environment is far more extreme than first imagined. The planet orbits so close to its star that the radiation it receives is incredibly intense. The host star itself is a massive blue star that emits enormous amounts of ultraviolet energy. This radiation continuously heats the planet's atmosphere to extraordinary temperatures. In fact, the atmosphere becomes so hot that it begins to glow brightly. Powerful heat waves ripple through the thick layers of gas surrounding the planet. The atmosphere expands dramatically as the intense heat pushes gases outward. At these temperatures, ordinary molecules can no longer remain stable. Many chemical compounds break apart under the relentless stellar radiation. The entire atmosphere becomes a violently heated ocean of gas. Energy from the star spreads across the planet through powerful atmospheric currents. These currents transport heat from the star-facing side to the darker regions of the planet. Even the cooler side of the planet remains extremely hot by planetary standards. Powerful stellar winds interact with the outer atmosphere of the planet. These winds can push atmospheric particles far out into space. Scientists believe the planet may be slowly losing parts of its atmosphere. Observations show that the atmosphere glows due to the intense thermal energy it contains. Using advanced telescopes, astronomers analyze this glowing atmosphere in detail. These observations reveal the extreme physics occurring on the hottest known planets. KELT-9b demonstrates how extreme heat can completely transform a planetary environment. The extreme temperatures on KELT-9b create conditions unlike any other known planet. At over 4,000 degrees Celsius, even metals cannot remain solid. Instead, elements like iron and titanium begin to vaporize in the atmosphere. These metals rise into the sky as glowing clouds of atomic vapor. The planet's atmosphere becomes a strange mixture of gas and metallic particles. Powerful atmospheric currents move these glowing materials across the planet. The horizon itself appears to glow under the intense heat. Instead of water clouds, the skies may contain clouds of vaporized metals. Scientists have detected evidence of iron atoms floating in the upper atmosphere. These atoms absorb and emit light, creating unusual spectral signatures. Intense radiation from the nearby star continues to energize these particles. The atmosphere expands and stretches far above the planet. High-speed winds distribute heat across the entire world. These winds carry metallic vapors around the planet at incredible speeds. Radiation constantly breaks apart molecules and reshapes the atmospheric chemistry. Streams of glowing gas flow across the planet like rivers of fire in the sky. The entire atmosphere becomes a laboratory of extreme physics. Observations of these metal vapors help scientists understand ultra-hot planets. KELT-9b reveals how extreme temperatures can transform the nature of a planetary atmosphere. It is a world where the sky itself may be filled with vaporized metal. As astronomers continue to study KELT-9b, they realize that this planet is slowly being destroyed by its star. The powerful radiation constantly bombards the planet's atmosphere. This extreme energy heats the gases until they expand far into space. Some of the atmosphere begins to escape the planet's gravity entirely. Streams of glowing gas can form as the atmosphere drifts away from the planet. Stellar winds from the nearby star accelerate this loss of atmosphere. Over time, the planet may lose significant portions of its outer layers. The intense ultraviolet radiation continuously erodes the planet's atmosphere. Scientists believe this process may be slowly shrinking the planet. KELT-9b may be gradually stripped down to its inner core. The massive blue star dominating the system is far hotter than our Sun. Its radiation environment creates one of the most hostile planetary systems known. Yet this extreme system offers scientists a rare opportunity to study ultra-hot planets. By observing how the atmosphere escapes, researchers learn about planetary evolution. These observations reveal how stars can dramatically reshape their planets. Worlds like KELT9b show how violent the universe can be. In distant star systems, planets can exist under conditions far beyond anything in our solar system. Some planets may glow from intense heat or lose their atmospheres entirely. KELT9b stands as a powerful reminder of the extreme diversity of exoplanets. In the vast universe, even planets hotter than lava can exist under the blazing light of alien stars.